Hello, my name is Brian Mikolajcyzk. I am a computer science master's student at Eastern Michigan University, and my project is called Marsnet, a neural network for predicting conditions in the upper atmosphere of Mars. My project uses the MAVEN neutral gas and ion mass spectrometer instrument, and this instrument takes abundances of ions and neutral gases. Major species are included, as well as several isotopes. And with this data, I want to feed it into a neural network and make predictions. The neural network I'm using is, the model is called a supervised feedback with learning model. And what this model does is it takes inputs, and the inputs I've chosen are the ion mass, ion abundance, solar zenith angle, and altitude. And the outputs of the neural network are going to be the neutral gas mass, neutral gas abundance, solar zenith angle, and altitude. We know that ions and neutral gases in Mars's upper atmosphere are tightly coupled, and that solar activity plays a large role in the fluctuations of these abundances. The way the network actually works is there are three layers: an input layer, a hidden layer, and an output layer. Each input layer is connected to each hidden layer, and each hidden layer is connected to each output layer. The data is ran through the network forward. That is, that each input layer node is a different input attribute, and each output layer is a different output attribute. And when an input is ran through the network, the output is checked for validity against the training data set, and if the output isn't similar to the input, then the network is updated. The updating occurs by updating weights and biases. Each node has a bias, and each line segment in between the hidden layer and the input layer and the hidden layer and the output layer have weights. These are adjusted based on the learning rate of the network. And once the network is trained, any input can be given to the network, and the output will be a prediction based on what the neutral gas mass and abundance should be. So far, I've used a permutation method on a subset of data, which takes each input ion as affecting every output neutral gas. And through this method, I was able to achieve an average training error of 7%, which is very good for a first attempt. I've recently gained access to NASA's high-end computing platform, and I hope to lower this training data and introduce the full data set to the neural network. Thank you.